All right, chemistry kids, here's Unit 6, Chemical Reactions. We just talked about the 5 major types of reactions, so if you haven't seen that video, make sure you watch that. And now what we're going to talk about is completing reactions. How can I describe the decomposition of a binary compound and identify a single or double reaction will occur and predict products. So basically identifying and trying to figure out what the reaction is going to do. All right, by knowing what type it is. So you got to know what type it is. So if you don't know this objective, make sure you go back and look at some videos for that. So here's our first one we're going to talk about. It says, I can describe the decomposition of a binary compound. All right, so decomposition. Binary means it's composed of 2. Okay, so this could be any example that you could think of. So let's throw down an example here. Let's say I give you this. Say, here's your reactants. What's going to happen? Well, you should know right away because you have one compound. Say, hey, this looks like a decomposition reaction. And the only thing a decomposition reaction can do is break into its parts. So, in this case, you're going to break the parts into its silver and sulfur. And that's it. Not too bad, huh? So let's try another one. Again, all you're doing is breaking it apart. Let's talk about this one. Aluminum and aluminum oxide. Well, what's going to happen? Well, I know it's going to break apart because it's decomposing. It's got a binary compound. The only thing it can do is break apart. So now I have aluminum, and now I have O2. Now the question is this: why do I have O2 here? Why, when it's by itself, does it have a 2? Well, and why doesn't this one have a 2? And why doesn't this one have a 2? And why doesn't this one have a 2? All right, but you should know why when they're a compound, where this 2 and 3 come from, and this 2 come from, because remember that's their charges, it's their oxidation numbers. That's what you dropped and swapped. So make sure you know how to drop and swap and know where those numbers came from. Here's what you got to realize: there's certain elements when they're written by themselves, okay, that means with nothing else, that are going to be O2s. They're called diatomics, okay? They're called the sneaky 7, okay? And here's a list of the sneaky 7. When they're by themselves, they're listed as this. So hydrogen's 1. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. There's your sneaky 7. When they are by themselves, like this oxygen is, where it's not attached to anything. Okay, notice over here, it's attached to something, so therefore it's not by itself. When it's by itself, they're written as 2. They're called the diatomics, okay, and there's a list of them on your periodic table. So recognize that if these ones are written by themselves, there should be a 2 for a subscript next to them. All right, so there's your decomposition. You start with a compound, you break it into its parts. And all you gotta do is make sure you watch out for your sneaky 7, like oxygen or hydrogen or any one of these 7 down here. All right, so let's move on to the next one. I can predict products of a chemical reaction. All right, so if you use the format that we used in class, you should be able to tell what type of reactions it's gonna be. So let's do an example of each. Let's say I give you this. Well, you should recognize from the other ones 2 elements. So I have 2 elements here, so what do they have to do? Well, if they're going to react, they're going to make something. So this is a composition or synthesis reaction, because remember, in a composition synthesis reaction, 2 elements make a compound. So now it's going to be Na, and I know that Na has a charge of 1 because it's in group 1. And oxygen has a charge of 2, so therefore I drop and swap, it should be Na2O. There's my synthesis or composition reaction. Next one, let's try a decomposition. Why not? Even though we just tried one. We can do another one. Let's go, let's say here. go this one. SiCl4. And I just gave you that and said, okay, figure out what's going to happen. Well, I know it's a compound to start with, and that looks a lot like a decomposition because you always start with a compound. Break it into its parts, it should be SiCl. Now I have to quick check, is there any diatomics here? Si is not, but Cl is, so that means there should be a 2 there. And there's a decomposition. Let's try another one. Let's try one that we haven't tried here. Let's go with this one. Cl2 reacts with NaBr. Well, what does it make? Well, right away you should go, I have one element and I have one compound. That's the sign of a single replacement. So this Cl is going to switch with the Br. So the big question would be, how do I know if it's going to switch with the Na or the Br? Well, chlorine's a nonmetal, it's going to switch with a nonmetal. Whereas if this was a metal, it's going to switch with the metal. So metals switch with metals and nonmetals switch with nonmetals. So now the Na now goes with the Cl and the bromine now goes by itself. Check for diatomics. Nope. Is bromine one of the diatomics? Or a sneaky 7? And yes it is, so it needs to have a 2 here. Alright. And then let's go with another one here. Let's see what we got. Let's go with this one. Okay, let's say I gave you this. I said, figure out what it is. Well, compound and a compound. Gotta be a double replacement. Anytime you have 2 compounds to start with, has to be a double replacement. Now you can look at it 2 ways. You can say the first one in the formula switches with the first one, or you could say the second one switches with the second one. Either way, you should get the same result. But remember, this CO3, this is carbonate, so that whole thing switches. So you got to be careful when you watch those. So now the H goes with the CO3, and the Ca goes with the Cl. And here's where you got to know your drop and swap. I know the hydrogen's a +1, carbonate's a 2, drop and swap, it should be H2CO3. And I know that calcium's a 2 charge, and I know that chlorine's a 1 charge, and there should be a 2 next to the chlorine because it dropped and swapped. Alright? Anytime you have 2 compounds, simply double replacement. And the last one, any telltale sign, you should look at it and say, oh, this one should be easy, because combustion reactions are very easy to tell because anything reacts with oxygen. So I could say C4H10. Well, here's a hydrocarbon. It's reacting with oxygen. The only thing it can do when you burn it is form this stuff. So something reacts with oxygen, that tells you it's a combustion reaction, and therefore I'm always going to get these 2 products. Alright, hope this video helped predicting some things, and we will talk to you guys later.